Hi guys, welcome. Today we'll write in a script that gets a photo like this as input, detects the human faces, blurs them out, and saves the blur version beside the normal photo. For this we will use opencv module, which lets us do the face detection easily in less than 30 lines of code. Let's get started. Let's install opencv. In your terminal of choice, enter pip install opencv_python. While the module is getting downloaded and installed, go to your browser, enter this URL that is in the description box of the video. You should see hard cascade frontal face default.xml. Click the raw button, then right click the raw page and choose save as. That opens a file dialog for you to choose the destination of the download. I recommend downloading it to the directory that your script is. I already have it in the Python directory where my script is. Now that requirements are met, let's import cv2, which is the opencv module that we installed. Create face cascade variable and assign it cv2.cascade classifier. Then grab the name of the file that we downloaded earlier and pass it to the classifier as a string. As I said, if the file is in the same directory as your script, you can just pass the name, otherwise you should pass the path to XML file. Then you want to take the user input using input function and ask for the image that user wants to blur the faces in that image. And save it in user input variable. Now you read the image that user has provided by passing it to cv2.imread and save it as image. In order to detect faces in the image, we need to first convert the colored image to gray, so gray equals cv2.cvdcolor, and we first pass the image, and second the method that we want to use, which is cv2.color_bgr to gray. Then faces equal to face cascade.detect multiscale. First parameter is gray, second one is the scaling factor, which I set to 1.1, and third min neighbors, which I set to 5. So detect multiscale grabs the gray image and detects faces in the image based on the factors that we set. You can play with the factors to see what's the best for you. Faces variable stores 4 parameters for each face rectangle that it finds: x, y, height, and width. For x, y, h, w in faces, face_ROI equals to image, brackets open, y colon, y plus h, x colon, x plus width. Image is a matrix, and here we are slicing it and grab the face rectangle that is detected and store it in face_ROI, which stands for region of interest. Then blur equals to cv2.medium blur. First we pass the face region of interest and then an odd number. The higher number, the higher blur. So far we have grabbed the detected faces and made a blur rectangle exactly the size of the faces. Now we should place the blur effect upon the faces. For that we copy the sliced image and assign it the blur effect. Out of the for loop, we call cv2.imshow to show the image. First parameter is the name of the window and second one is the picture that we want to show, which is image variable. Next we call cv2.imwrite to save the blurred image. First parameter is the name of the file that we want to save. I have JPEG image files, so I grab the name of the image and slice it and remove last 4 letters of the name, which is .jpeg extension, and concatenate it with _blur.jpg. This prevents overwriting your main images. If your image have different extensions, change the slicing to fit your situation. Second parameter is the image that you want to save, which is image variable. Finally, we have to call cv2.waitKey, which creates a loop for showing the image and lets us close the image with pressing a key. Here I got 3 JPEG image files named test, test2, and test3. Let's see if the script works. First, I want to blur test3.jpg. It works, but the image is too large and we need to downscale it. Resize the image equals to cv2.resize. First is the image, second one is the desired size, a tuple of 0 and 0. Third and fourth parameters are fx and fy, which are both 0.05, and we show the resized image. Let's see the result. All the faces are perfectly detected and blurred, but there are some other areas that have been detected as faces wrongly. Second image too, but if you look sharply, program has detected the feet as a face. And last image, as you see, is not good at all, but by playing around with the parameters, you can make it better and better. And all the images are successfully saved. That's it guys, we made a face detector in less than 30 lines of code. Please like the video if you enjoyed it and subscribe to the channel for more cool stuff. Take care, see you later.